Good morning. In this session, we will be learning conversion of NFA with epsilon moves to NFA without epsilon moves. First, we'll understand the example, then we'll try to connect that with the concept of conversion. Okay, so this is our NFA. Q0 is the start state and Q2 is the acceptance or final state, and this is the transition table for the same. Say for example Q0, if the input is A, goes to Q1. Similarly Q2, if the input is B, it goes to Q2. Like that we have prepared the transition table. Now first we need to find out the epsilon closures of all these states whenever we want the conversion of NFA with epsilon to NFA without epsilon. So this is epsilon, right? So whenever epsilons are there, it's NFA with epsilon. What is our target? We have to convert this into NFA without epsilon. We have to convert this into NFA without epsilon. So for Q0, Q1, Q2, we have to find out the epsilon closure. We have to find out the epsilon closure. Now, what is the epsilon closure? It's the reachability of a state through epsilon to the next all possible states. Say for example, Q1 is there. Through epsilon, we can reach Q2. So the epsilon closure of Q1 will be Q1 and Q2. Similarly, Q0 is there. So there is no epsilon reachability. So epsilon closure of Q0 is Q0. Epsilon closure of Q1 is Q1 itself and Q2. So it's Q1 comma Q2. And epsilon closure of Q2 is Q2 itself. So once we found out the epsilon closures, then we have to find out the transition. Delta dash of Q0 comma A. Q0 is the initial state, A is the first input. Now this can be found out using this formula. We have to find out the delta dash of Q0 comma A because we want to convert NFA with epsilon to NFA without epsilon. For that, the formula is epsilon closure of delta dash of Q0 comma epsilon comma A. And what is this Q0 comma epsilon? Q0 comma epsilon is epsilon closure of Q0. And what is epsilon closure of Q0? Q0. So it will be delta of Q0 comma A. So what is delta of Q0 comma A? Delta of Q0 comma A is Q1. And what is the epsilon closure of Q1? It is Q1 Q2. So this will lead to Q1 Q2. Similarly, we have to find the delta dash of Q0 comma B. Q0 comma B. So same formula. Epsilon closure of delta dash of Q0 comma epsilon comma B. So Q0 comma epsilon closure of Q0. So epsilon closure of Q0 is Q0. So Q0 comma B, delta of Q0 comma B, delta of Q0 comma B is phi, nothing. So that will be epsilon closure of phi will be phi. Similarly, delta dash of Q1 comma A. So that will be epsilon closure of delta dash of Q1 comma epsilon comma A. So here Q1 comma epsilon indicates epsilon closure of Q1. What is the epsilon closure of Q1? Q1 comma Q2. So epsilon closure of Q1 is Q1 comma Q2. So now we have delta of Q1 comma Q2 comma A. So this delta of Q1 comma Q2 comma A can be found out using delta of Q1 comma A union delta of Q2 comma A. So delta of Q1 comma A will be phi and delta of Q2 comma A will also be phi. So that will be phi union phi, epsilon closure of phi union phi will be phi only. So now we are finding the delta dash of Q1 comma B. Same formula, epsilon closure of delta dash of Q1 comma epsilon comma B. So Q1 comma epsilon indicates the epsilon closure of Q1 and epsilon closure of Q1 is Q1 comma Q2. So this will be again a union of delta of Q1 comma B and delta of Q2 comma B. So Q1 comma B, Q2 comma B. Q1 comma B will be phi, Q2 comma B will be Q2. So that becomes Q2. So phi and Q2. So epsilon closure of Q2. What is the epsilon closure of Q2? The epsilon closure of Q2 is Q2 itself. The epsilon closure of Q2 is Q2 itself. That comes to Q2. Then delta dash of q2 comma a is epsilon closure of delta dash of q2 comma epsilon comma a. This q2 comma epsilon indicates epsilon closure of q2, and epsilon closure of q2 is q2. So delta of q2 comma a, and delta of q2 comma a is phi. So epsilon closure of phi is phi only. Similarly, delta dash of q2 comma b is epsilon closure of delta dash of q2 comma epsilon comma b. So this is a q2 comma e is epsilon closure of q2, and epsilon closure of q2 is q2. So delta of q2 comma b. So delta of q2 comma b is q2, and epsilon closure of q2. So what is the epsilon closure of q2? Epsilon closure of q2 is q2 itself. Epsilon closure of q2 is q2 itself. So now using these transitions, we'll be drawing the transition table. We'll be drawing the transition table. So this transition table is without epsilon. This transition table is without epsilon. What are the states? Q0, Q1 and Q2. What are the states? Q0, Q1 and Q2. Now, which states are final states? So whichever states in their epsilon closure have the final states. Here, which is the final state? Q2 is the final state. So Q2 is in epsilon closure of Q1 and Q2 is in epsilon closure of Q2. So Q1 and Q2 both will become the final states. Q1 and Q2 both will become the final states. As you can see here, you can mention here Q1 and Q2 are both the final state. Q0 is the initial state. Now, delta dash of Q0 comma A. Let us look at delta dash of Q0 comma A. Delta dash of Q0 comma A is coming to as Q1 comma Q2. So here Q1 comma Q2. Delta dash of Q0 comma B is 5. Delta dash of Q1 comma A is 5. Delta dash of Q1 comma B is Q2. Delta dash of Q2 comma A is 5. Delta dash of Q2 comma B is Q2. So using this transition table, we'll be drawing the transition diagram. Which are the final states? Q1 and Q2 are the final states. Why they are the final states? Because the epsilon closures of Q1 and Q2 have the final state Q2. So that's why we have drawn this transition diagram using the transition table. Simple. So Q0 input A will go to Q1 and Q2. Q0 input A will go to Q1 and will go to Q2. So similarly, Q0 input B will go to 5. Q0 input will go to 5. Q1 input A will go to 5, means nothing. Q1 input B will be Q2. Q1 input B will be Q2. So Q2 input A is nothing. Q2 input B is Q2. Okay. So this is the NFA with epsilon conversion to without epsilon. Thank you.